Light feels familiar. You switch on a lamp, the room brightens. You see, simple from childhood. We're told a comforting story. Light travels from a source, moves through space, and enters your eyes. Fast, but understandable. Mysterious, but manageable. And for most of your life, that story works. Until you look closer. Because the moment physicists truly examine light, not with intuition, not with metaphors, but with mathematics, something deeply unsettling appeared. Something Richard Feynman himself found. Disturbing the illusion of understanding, ask almost anyone what light is. And you'll hear a confident answer. Light is a wave, or light is made of particles called photons. Both answers sound correct. Both answers are taught in schools, and both answers are dangerously incomplete, because the real problem isn't what light is. The problem is that light refuses to behave like anything else in reality, not matter, not energy, not even time itself. And Feynman knew this better than anyone. Feynman's quiet discomfort. Richard Feynman was famous for making hard ideas sound simple, but there was one topic where even he slowed down. Light. In his lectures, when he spoke about photons, his tone suddenly changed. The jokes faded, the certainty softened. At one point, Feynman admitted something most physicists avoid saying out loud. I think I can safely say that nobody understands quantum mechanics. And light sits at the very heart of that confession, because photons, the particles of light, do something no common sense explanation can survive. Light does not experience time. Here's the first crack in reality. From your perspective, light travels incredibly fast, about 300,000 kilometers per second. But from light's perspective, there is no journey, no movement, no passage of time, no distance for a photon. The moment it is created and the moment it is absorbed are the same moment. This isn't poetry. It's mathematics. According to Einstein's relativity, which Feynman deeply respected, time slows down as speed increases. At the speed of light, time stops entirely, which means light does not travel the universe. It simply exists at its destination. Let that sink in. The sunlight paradox right now. Sunlight is touching your face. That light was emitted by the Sunday about 8 minutes ago, traveling across 150 million kilometers of space. That's what you experience. But the photon itself, it was born in the Sunday and died in your eye in the same instant. 8 minutes for you, 0 time for light. So what does it mean to say light moves? Already, the story you were taught is unraveling. Wave or particle? Yes. Number both. Neither. Now things get worse. Light behaves like a wave. It interferes with itself. It spreads. It creates patterns. But light also behaves like a particle. It arrives in discrete packets. It clicks detectors one photon at a time. Feynman called this the central mystery of quantum mechanics. Not because it's confusing, but because it refuses to be resolved. When you test light as a wave, it becomes a wave. When you test it as a particle, it becomes a particle. And when you don't look, it behaves as if it is everything at once. The double-slit shock. This is where Feynman stopped calling things strange and started calling them impossible. In the famous double-slit experiment, single photons are fired one at a time at a barrier with 2 tiny openings. No matter how slowly you fire them, no matter how carefully you measure, the photons create an interference pattern, as if each photon went through both slits simultaneously, one particle, 2 paths. But the moment you place a detector to see which slit the photon passes through, the interference disappears. Light suddenly behaves like a normal particle again. Reality changes based on whether you ask a question. Observation is not passive. This is the moment physics becomes personal. Because observation isn't just noticing what happens. Observation forces reality to choose. Feynman emphasized this again and again. It's not that we don't know which path light takes. It's that the path does not exist until measured. Before observation, light exists as a cloud of possibilities. After observation, it snaps into a single outcome. Not because of consciousness, not because of belief, but because measurement itself is an interaction. And interaction changes the system. Light as a messenger of reality. Everything you know about the universe comes to you through light. Stars, galaxies, atoms, your own reflection. Light is not just something in the universe. It is how the universe reveals itself. And yet, the very thing we rely on to understand reality refuses to obey reality's rules. Feynman once said that nature isn't classical, and if you try to force it to be, you'll be wrong. Light is the proof. A subtle, terrifying implication. If light does not experience time, if light does not choose a path until observed, if light exists as probabilities, not facts, then what does that say about the reality it illuminates? Are objects solid when unobserved? Is time flowing when nothing measures it? Is the universe quietly undecided? Feynman never gave comforting answers here. He simply showed the logic and let the discomfort remain. Chapter 1 closing. Retention lock. The light in this room feels calm, harmless, obedient, but physics says that every photon around you is doing something impossible, something that cannot be drawn, imagined, or explained without contradiction. And this is only the beginning, because once Feynman followed light far enough, he realized something even more unsettling. Light may not be revealing reality at all. It may be hiding how little reality actually exists. In the next chapter, we'll follow light into space itself and discover why empty space is one of the most violent ideas physics has ever produced. The most dangerous word in physics. Empty, we use the word empty casually. An empty room, empty space, nothing there. It feels harmless, but in physics, the word empty is a trap. Because the moment you truly follow light into what we call empty space, the idea of nothing collapses completely. And this is where Feynman became deeply uncomfortable. Light does not travel through nothing when light moves from the Sunday to Earth. We imagine it passing through vast, empty darkness. No air, no matter. Nothing in the way, but physics tells a different story. According to quantum theory, space itself is an active participant. Light does not glide through nothingness. It interacts with the vacuum, and that vacuum is anything but quiet. The vacuum that refuses to stay still in classical physics. Empty space is simple. No particles, no energy, no activity. But quantum mechanics shattered that idea. Feynman explained that even in the lowest possible energy state, what physicists call the vacuum, space is still alive with activity. Particles appear, particles disappear, energy fluctuates, not because something causes it, but because nothingness is unstable. Virtual particles, ghosts of light out of this quantum vacuum. Pairs of particles constantly flicker into existence. Electron and positron, particle and antiparticle, they exist for such a short time that they can't be directly observed. But light feels them. As a photon travels through space, it interacts with these fleeting particles. Pairs it is constantly being absorbed and emitted, slowed, deflected, altered, which means something shocking. Even the speed of light depends on the structure of empty space. Why light has a speed limit, most people think the speed of light is just a number, a cosmic speed cap, but Feynman emphasized that the speed of light isn't about light, it's about space and time themselves. Light travels at the maximum speed the universe allows because space-time won't let information move faster. That limit exists even where there is nothing. Which tells us something profound. Empty space has rules. Empty space has structure. Empty space has tension. The fabric light is forced to obey light, doesn't just illuminate the universe. It exposes the stiffness of reality. When photons move, they reveal that space behaves like a medium, almost like a fabric that resists change. Not a substance you can touch, but not nothing either. Feynman compared this to trying to describe water to a fish. The fish doesn't notice water, but everything it does depends on it. We live inside space the same way, and light is the only thing fast enough to expose its hidden properties. The Casimir shock, one of the strangest confirmations of this, came from an experiment Feynman loved to discuss. Place two metal plates extremely close together in a vacuum. No air, no particles, just empty space. According to classical logic, nothing should happen, but the plates are pulled toward each other. Why? Because the vacuum between them is different from the vacuum outside. Quantum fluctuations are restricted. Thus, nothing exists between the plates than outside them, which means nothing has pressure. Let that sit for a moment. Light feels the weight of nothing when light passes through space. It isn't gliding freely. It is constantly negotiating with these fluctuations. Every photon is interacting with a seething background of temporary particles. The universe is not a stage where events happen. The stage itself is moving, vibrating, resisting, and light is our only reliable probe of that motion. Why darkness is never truly dark, even in the deepest voids between galaxies. Space glows faintly, not with stars, but with leftover radiation. Quantum noise, vacuum energy, background fields. Light reveals that darkness is a lie, we tell ourselves, because our eyes are limited. Reality never turns off. Feynman's uneasy realization. Feynman didn't like mystical language, but when it came to the vacuum, even he admitted something strange. The laws of physics allow energy to exist where nothing should be. And if space itself contains energy, then gravity must respond to it. Which leads directly to one of the greatest unsolved problems in physics, the vacuum catastrophe, according to quantum theory. The vacuum should contain enormous energy, enough to rip the universe apart, but it doesn't. The observed energy of empty space is tiny, off by a factor of 10 Fundy, the worst theoretical prediction in the history of science. Light reveals the vacuum reveals a contradiction. And physics has no answer. A universe balanced on a knife edge, if the vacuum energy were slightly larger. Galaxies would never form, stars would never ignite, life would be impossible. If it were slightly smaller, the universe might collapse. Reality exists in a narrow window, balanced, unexplained, and light is the messenger bringing us this unsettling news. The emotional truth we avoid, we like to imagine the universe as solid, stable, predictable. But light tells a different story. It shows us a reality built on fluctuations, probabilities, and delicate cancellations. A universe that works. But only barely. Feynman once said nature uses the longest possible path to get things done. The vacuum proves it. Chapter 2 closing. Retention lock empty space isn't empty. It is restless, energetic, unresolved. And light, by simply existing, forces us to confront that fact. But this raises an even more disturbing question. If space itself is unstable, and light doesn't experience time, then what does time actually mean? And is it as real as we think? The feeling that never questions itself right now. You feel something moving, a quiet, unstoppable flow, from past to present to future. Time feels so obvious that questioning it seems pointless. But physics doesn't care about how things feel. And when light enters the story, time begins to fall apart. Time exists for you, not for light. We already touched the first fracture. Light does not experience time. For a photon, there is no waiting, no duration, no before or after. Creation and absorption are the same event. This alone should make you uneasy, because light is not exotic matter. It's everywhere. It's the fastest thing that can exist. If time disappears at light speed, then time cannot be fundamental. It is conditional. Feynman's reluctant honesty about time. Feynman rarely philosophized openly. But when students asked about time, he never pretended it was settled. In his lectures, time appears not as a flowing river, but as a parameter, a label we attach to change. Physics does not require time to move. It only requires relationships between events. And light exposes that brutally. Simultaneity is a lie. Here's where everyday intuition collapses. You think now exists, a universal present moment shared by the entire universe. But relativity says otherwise. Two events that appear simultaneous to you are not simultaneous to someone moving relative to you. There is no cosmic clock, no universal now. Light enforces this because the speed of light is constant for all observers. Time must bend to preserve that rule. So the universe sacrifices simultaneity. The shocking consequence, there is no single present moment. There is no objective past. There is no fixed future. Different observers slice reality into time differently. All moments exist, but not in the way you imagine. This idea is sometimes called the block universe. Feynman didn't popularize the term, but the mathematics supports it. Reality is not unfolding. It is already laid out. Light connects all moments because light experiences no time. It links distant events as if they are adjacent. A photon emitted billions of years ago from a distant galaxy reaches your eye without aging. From its perspective, the early universe in your retina touch, which means the past is not gone. It is connected, still participating. Why the past refuses to stay dead, this isn't philosophy. It's physics. Light from ancient stars still shapes reality today. Cosmic background radiation still influences the structure of the universe. Events do not vanish. They echo. Feynman once emphasized that physical laws work equally well forward and backward in time. The equations don't care which direction time points, so why do we? Entropy. The only arrow there is only one reason time feels directional. Entropy disorder tends to increase, not because the laws demand it, but because certain states are overwhelmingly more probable. Feynman made this clear. Time's arrow is statistical, not fundamental. If entropy defines time's direction, then time is an emergent phenomenon, not a basic ingredient of reality. Light doesn't care about entropy, light doesn't age. Light doesn't decay, light doesn't remember. It simply connects events. Entropy governs systems with many particles. Light often travels alone, which means it escapes the very thing that gives time its direction. Another crack: the present moment is a construction your brain stitches together, sensory information using light. But there is always delay. You never experience now. You experience light that left objects fractions of a second ago. Even your own body is slightly in the past. The present moment is a neurological illusion, assembled after the fact. Physics agrees. Why this disturbed Feynman? Feynman loved clarity, and time is anything but clear. Light reveals that time stops at extreme speeds, depends on the observer, has no universal present, emerges from statistics. This isn't a mystery with a solution waiting. It's a sign that time may not be what we think it is at all. A dangerous thought experiment. Imagine freezing the universe. Every particle, every field, every interaction. Now remove the label time. Would physics break? Surprisingly, no. The equations still relate events. Only our interpretation collapses. Time might be a story we tell to make sense of change. Light is the universe's editor. Light edits reality. It decides what can influence what counts as cause and effect, what can be known. Without light's speed limit, time would lose coherence entirely. So time bends to protect light, not the other way around. The emotional consequence we avoid if time isn't fundamental. Then aging is not built into reality. Then death is not written into the universe. Then change is not mandatory. It is emergent, conditional, and fragile. This doesn't make existence meaningless. It makes it terrifyingly subtle. Chapter 3, closing, retention lock light, shows us that time doesn't flow. It fractures, it depends, it dissolves under scrutiny. And if time is an illusion, then the deepest assumptions you have about reality may be stories, not facts. But the disturbance doesn't stop here, because once Feynman followed light far enough, he encountered a question even more dangerous than time. The question physics tried to avoid for centuries. Physics was built on a comforting assumption. Reality exists whether you look at it or not. Planets move, stars burn, light travels. Observation was thought to be passive, a camera, not a participant. But light destroyed that idea. Feynman's line in The Sand Feynman was brutally honest about one thing. Quantum mechanics does not describe what is. It describes what happens when you measure. That distinction changes everything, because light behaves differently depending on whether it is observed, not interpreted, not believed. Simply observed, the double slit, revisited by now. You know the outline. Single photons fired one at a time. Two slits, an interference pattern. Light acts like a wave, but add a detector to observe which slit the photon passes through. The wave disappears. The photon becomes a particle, no energy change, no force applied, just information gained. Reality rewrites itself. Observation is an interaction. This is where misunderstanding begins. It's not consciousness that changes light, it's interaction. To observe a photon, you must interact with it. That interaction alters the system. But here's the disturbing part. Even the possibility of knowing changes the outcome. You don't need to record the data. The universe knows whether the information is available. Delayed choice. When the present changes the past, John Wheeler pushed this further with a thought experiment Feynman loved. What if you decide how to observe light after it has passed the slits? Wave behavior or particle behavior is determined retroactively. The choice made in the present determines how light behaved in the past, not metaphorically. Physically, light has no fixed history in quantum mechanics. Light does not carry a definite story, only probabilities. The past is not settled until the present demands it. Feynman emphasized this unsettling truth. Physics does not describe history. It describes correlations between measurements. Reality is a set of questions instead of a universe filled with objects. Quantum mechanics presents something stranger, a universe filled with questions. What is the position? What is the momentum? Which path? Light answers only the question you ask, and refuses to answer the rest. Why, this isn't philosophy. This isn't abstract debate. These effects are measured, repeated, used. Every quantum computer. All depend on light obeying rules that defy classical reality. Feynman's calculational escape faced with this madness. Feynman did something clever. He stopped asking why. Instead, he invented a method to calculate outcomes without pretending to understand them. Feynman diagrams don't show what happens. They show what contributes. Paths, probabilities, amplitudes. Reality becomes a sum over possibilities. Light takes every path, according to Feynman's formulation. A photon explores every possible path between 2 points, straight lines, curves, loops, even paths that go backward in time. Most cancel out. Only a few survive. The path you observe is not chosen in advance. It emerges from interference. The observer trapped, this leads to a trap physics cannot escape. If observation defines reality, an observation requires interaction, and interaction involves physical systems. Where does the chain end? Does the measuring device observe light? Does the environment observe the device? Does the universe observe itself? There is no clear bound. The collapse we can't explain. When a measurement happens, probabilities collapse into a single outcome. But physics has no mechanism for this collapse. No equation describes it. It is simply assumed. Feynman admitted this openly. The most successful theory in history cannot explain its own core process. Why light is the perfect culprit, light sits at the center of this paradox. It is massless, fastest possible, ubiquitous, the carrier of information. If anything reveals the rules of reality, it's light. And what it reveals is deeply uncomfortable. The emotional shock we resist. We want reality to be solid, independent, unquestionable, but light suggests reality is contextual, dependent on interaction, defined by relationships, not objects. This doesn't mean nothing exists. It means existence is subtler than solidity.